Oh, jeez. Lexi, where do you think there are vertical asymptotes, if any, on the first example? Plus or minus 2. And what thought process led you to that?
Because you can't take the natural log of 0.
Okay, so we know that if z is 2 or negative 2, you'd get 4 minus 4, which is 0. You can't take the log of 0, okay? How do you know they're an asymptote versus just an undefined value?
Because it
approaches it.
Yeah, if you look at it in terms of the parent graph.
Do you know what the parent graph is?
ln of x, yeah.
Well, but then when you, yeah, we do know what the natural log of x is, but this is x squared. So I guess the only, I'm just being the devil's advocate for Lexi, because if you tried plugging in 1, you'd have a problem as well, but you're not telling me that 1 is an asymptote because you can't take the log of a negative. So why is 2 an asymptote but 1 is not? Right, because the entire, this is really like the border of where it exists versus where it doesn't, right? And yes, there is some parent graph stuff in there because we know that the border of where it equals 0, what you're trying to take the log of, that will be an asymptote, and anything on the other side just doesn't exist. So the graph for this looks like this. And those are asymptotes, I believe. What's it going to be? It's going to do something like this. Not that we needed that, but yes, those are the asymptotes. So wherever log is 0, that's an asymptote. If you're trying to take the log of a 0, that's an asymptote. Whatever x value makes that happen. If it's the log of a negative, that's not an asymptote. That's just where the graph doesn't exist. Do we follow that? Okay. How about the second exercise? Tan of x over x. Thoughts? Hannah. What do you think? Hannah wants to just give the answer. Go ahead. So odd pi's over 2.
Yeah.
K pi over 2, where k is an odd integer. Okay. What's she missing? Does anybody have something else that she's missing? Hannah. 0. Which you're saying because, right, tan of 0 over 0, it's over 0, so that's another undefined. Who did not have 0?
What's 0?
Hannah Fox, you obviously didn't list a 0. Mackenzie didn't, Nick didn't. Okay, so Nick is saying that 0 is not an asymptote. Why and how would you know that is the question, right, Hannah? Because he's right. So how does Nick know that? And that didn't even cross my mind. So go ahead, Nick.
I grabbed it on my calculator.
That's illegal. You don't have a calculator.
Is it because...
Hold on. Kristen wants to give it a whirl. Oh.
I did. Well, I went back down, but then I went back, and then I came back down.
So you don't want to give Mackenzie.
Because you can manipulate it, so it's not. So it's
Be-
not undefined.
Okay, so manipulate it how?
Change the sine over cosine times 1 over straight up.
So she's keeping the tangent as sine over cosine, changing division to multiplication, and flipping theta to 1 over theta. So when you do that, you have this, which is essentially the secant graph, which definitely has lots of asymptotes. And then this graph, though, it's not an asymptote at 0. This is the graph that we looked at where the limit as theta approached 0 was 1. Even though it's undefined at theta equals 0, it's not because it's an asymptote. It's because the graph of sine theta over theta looks like this. So with kind of a couple different angles with the manipulation and knowing that this graph certainly has asymptotes, but this graph does not, tells you that that theta alone as a 0 in your denominator, yes, it makes it undefined, but it's not an asymptote, it's a whole. Okay? You were right. But I knew there was a bunch of people that put 0. Because we're just going to.
I didn't actually put 0, but I thought you were really choosing us.
So undefined, so why did you not put 0 then?
Because I didn't think about it.
Oh, okay, so for a different reason, so you gotta get lucky.
Yeah.
Okay, but so when you look at a function to start, of course there may be undefineds. Every undefined isn't an asymptote, and you have to kind of look further. Is the undefined a whole? Is the undefined value an asymptote? Or, in the case of taking the log of a negative number, does that undefined value just not even exist because of a domain issue? So a couple things to think about there. Good. So on the bottom here, these 4 examples, when you're asked to find the one-sided limit, before you get started, think about asymptotes, where they would be, and then if you're approaching an asymptote, you need to be more specific about positive infinity or negative infinity. So take a few minutes and try that, and we'll discuss these as well. Okay, so on the first exercise, is 1/2 an asymptote? Let's start there.
Yes.
Okay, certainly when you plug in 1/2, you get an undefined. But is it an asymptote? And I'm hearing a lot of yeses. Why do you know that?
I don't.
Because it doesn't
Why do you
exist.
think that? Because why, Nick?
Well, tangent of pi over 2 is
Right.
9. So,
And why is it an asymptote versus a whole?
because there's nothing not.
How do you tell?
No, you needed something in the denominator to have a whole, like, so you made a rational function.
Well, tangent.
Oh, great question. I gotta think about it. Patrick says, don't you need something in the denominator to make it a whole?
So,
Because wholes comes from the nature of like factoring and canceling, or the sine x over x, or the, I like it.
So is that true?
I think so. I gotta think about all of the possible holes in the world, but it seems,
Okay.
yes.
So,
Wait,
It's
I
a-
missed that.
Patrick has a good hypothesis that we're gonna think about if we can come up with a counterexample, and he said,
yeah, but just
doesn't a whole require something in the denominator? Does he have a counterexample?
No, Kristen does.
No,
My
I'm
text
not
fair.
just
Like, I'm
Kristen.
not asking.
Kristen,
What?
what's the counterexample of a whole that doesn't?
No, it's not that. It's just that.
It's
It's
because
because
tan
tan is sine over cosine.
Yeah, just
Yeah.
like it is a fraction.
So there is a denominator.
Could be.
oh, I see what she's saying.
I see what you're saying too. So it could be written as a, in this case. So, but that's an interesting, holes do really come from that cancellation
You
thought.
only have a whole from a rational function.
No, it's not.
The ones we've seen, I mean, I don't know all the functions. I don't know with certainty, but definitely the ones that we've seen have been, right?
Okay, so all the questions we're gonna get, if it's not a rational.
I'd have to go back and look at them all, but all the holes I know of.
Yeah, we only
Yes.
have 15, no, not even yet, we only have 15 minutes left.
So the reason that Nick's gut is correct, why this is an asymptote, is because we do know the nature of a tangent graph. And a tangent graph has asymptotes at pi over 2, at 3 pi over 2, at 5 pi over 2. Those undefineds are asymptotes when you look at them graphically. So when you plug in a 1/2 and you get the tangent of pi over 2, that undefined does present as an asymptote at 1/2. So then, knowing that it's an asymptote, you've got to decide when it approaches it from the right, is it going towards positive infinity or negative infinity? So let's plug in something slightly greater than 1/2, and I'm going to think about the tangent parent graph first. So if I'm approaching 1/2 from the right, I'm going to be slightly greater than pi over 2. And our tangent parent graph does this. Now, there's more than just this tangent going on though. So based on our limit properties, if you're trying to find the limit of a function times a function, we can split it up into x approaches 1/2 from the right on x squared, and then you can multiply it by the limit as x approaches 1/2 from the right on the tangent of pi x. So this one can be directly evaluated as just 1/4. The right and the left doesn't matter on this piece because that's not an asymptote. This one, though, is the part that has the asymptote, and if you're approaching 1/2 from the right, your tangent graph is approaching pi over 2 from the right, which is negative infinity, and 1/4 times negative infinity is negative infinity. Okay?
I don't understand how,
Yeah.
what's the 1/4?
There's two functions being multiplied here.
Yeah, I get that, but like, it's
The 1/4 is the limit of this function on its own. It doesn't affect it at all. Because negative infinity times a number, as long as it's a positive number, is still going to be negative infinity. But negative infinity times a negative number would have changed it to a positive infinity.
oh,
Okay? So it can have a role in your answer, but it doesn't really here because whether you're at negative infinity or negative infinity times a quarter, it's still going towards negative infinity. One more second, Patrick. The other way of thinking about this is to actually think about tangent when you go around the unit circle. All students take calculus. If you plug in 1/2, you're right here. You're taking the tangent of pi over 2. If you, and tangents are 0 at 0, and then they increase until they're undefined, and then they decrease again towards 0. But if you plug in something slightly to the right of 1/2, it's going to put you right here in your unit circle, just past that undefined. So it's a very big number, because these are increasing from 0 up to big numbers, the closer you get to the y-axis. And it's going to be a negative, very big number, because you're in a quadrant where tangent is negative. So this is a very large negative number. The closer you get to the vertical undefined, meaning the closer you get to 1/2 coming from the right, you're going to get an even bigger and bigger number. So you can do it. I think graphically is definitely the easier way here, just knowing what the parent graph of tangent is like, but you can definitely think of it from a plug-in perspective as well. Patrick.
What if you have negative infinity squared? Is that positive infinity?
Yes. Second example.
1.
And yellow, what'd you have?
0.
0. Reason?
Okay, so this
And yellow?
was 1
No
times
asymptotes.
sine of that.
There's no asymptotes. Who said that? And yellow, or did someone over there tell you that?
I said that.
On your side.
And yellow, why do you know there are no asymptotes?
Why do you doubt her?
I don't doubt her. I just want her to explain it.
Well, on the side graph, there's no asymptote.
Correct.
Zero.
Correct. Well, in either graph, this is just an exponential growth, might be decay, but whatever, it's an exponential graph, one way or the other. That's continuous. Sine graphs are continuous, so we don't have any undefineds here. So they sort of mislead you, and that's, I just pulled this from an even question on your homework. They sort of mislead you by saying from the right. They kind of lead you to believe it's an asymptote. But if it's not, Hannah Webb, I think you need to go over there, please. If you go from the right and from the left, you're overcomplicating things here. So the first thing should be, is it an asymptote? Do I even need to worry about from the right or from the left? And if it's not an asymptote, then that plus or minus, whether it's from the right or from the left, is ignorable. So you just plug in 0, e to the 0 power is 1, 1 times the sine of 0 is 0, so 1 times 0 is 0. And the next one. Oh, Sam. You didn't get to it, or you didn't?
I didn't get to it.
You didn't get to it. Did anybody get to it that has a gut?
Nope. Negative infinity.
Not a god.
This is right.
Mackenzie got positive infinity. Did you really, or did you just yell that out?
No, I really got
Okay,
that.
she got positive infinity and Hannah got negative infinity. So the one thing they seem to be agreeing on is that it is an asymptote. Yes? Secant is the same as 1 over cosine.
Wait, just kidding.
Oh, Mackenzie just
She backed down.
backed down.
No,
She found a mistake.
I signed up for my seat.
Okay, that's fine. So why are we pretty sure it's an asymptote? Because when you plug -1 into this, because we know the nature of secant graphs, and that secant graphs have a lot of asymptotes, you plug in -1, you get the cosine of negative pi over 2. Well, here's your cosine graph. Cosine of 0 is 1, and then it decreases to 0, and it decreases to 0 as you move through your quadrants, going whether forward or backwards. So if you're taking the cosine of negative pi over 2, that answer is 0, so 1 over 0 is an undefined. The cause is an asymptote, will show up as an asymptote on a graph. So then the question is, if we're approaching that -1 from the left, like if you were to plug in a -1.1, this is going to make this angle slightly past, yes, like right here, the negative pi over 2, it's going to be slightly past the negative pi over 2, which is going to put you in a quadrant where cosine is negative, right? And it's just past 0, so it's a teeny tiny negative. Do we follow that? So 1 over a tiny negative tiny number is like negative infinity. And then the second function that they're just being at, their limits just need to be added together, that's not an asymptote at all, so you can just plug in -1 and you get -2. So negative infinity minus 2 is still negative infinity. What was your mistake, Mackenzie?
Oh, I like put the -1 before I moved the 1 over cosine, and I forgot to bring the negative down with my secant.
Gotcha. Okay, and the last one is very similar to that first graph we looked at. Like, we obviously can't take the log of a negative, so anything greater than 4 is good, and anything less than -4 is good. So 4 and -4 are cutoffs, and your cutoffs are what make you take the log of 0. And so in between, we can't do, because 0 squared minus 16 would be the log of a negative. So this whole section is in our domain. So coming on the other side of 4, so coming at it from the right, if you plugged in a 4.01, this number is going to be just above 16, so that when you subtract this 16, this is going to be a tiny positive number. Yes? The natural log of a tiny positive number is what? So the base is e raised to what is going to give us a tiny positive number. And you need to make a tiny number, you need to raise to a negative exponent. And the bigger that negative exponent gets, towards -1,000,000 or -10 million, the smaller that number will be, because like e to the -100 is 1 over e to the 100. So the bigger the denominator will get, which will cause the overall number to get smaller and smaller and smaller towards negative infinity, or towards 0, but this exponent is negative infinity. You need to raise e to a negative very large number to get a tiny number. Yeah. Because it's what do you need to raise e to? This equals question mark. So when we're trying to figure out what question mark is, the smaller the negative question mark gets, then the smaller that number will get. So negative 100, negative 1,000, negative 1,000,000, we'll make it all get smaller and smaller. Okie doke? True, false on the back. Number 1, the graphs of polynomial functions have no vertical asymptotes. Is this always true? Or can you think of a polynomial function that does have a vertical asymptote? What does what mean? What does a polynomial function mean?
Something with x to the power.
Yeah.
Like a times some coefficient with x to a power. Your power has to be an integer, has to be a positive integer. So
Some,
1, 2, 3, 4, 5.
It's true.
Right. So ax to the nth power plus some bx to the n minus 1. So your typical no fractions, no nothing. So that is true. A polynomial function will never have a vertical asymptote. And number 2, if f has a vertical asymptote at x equals 0, then f is undefined at 0. Correct, because we can never cross a vertical asymptote. So vertical asymptotes never have points on them.